the question on this one is to first put it in vertex form and then use transformations to graph it. Is that correct? Okay. This is a good problem, because I first have to get this in vertex form. If I'm going to get it in vertex form, I have to complete the square. Completing the square is how you go from, well, I take that back. I'm going to give you two ways to do it. Completing the square is how you go from standard form to vertex form. So let's do it by completing the square, and then let's do it a simpler way. All right? Is that a good idea? Okay, so completing the square. I can't complete the square unless I have a coefficient of 1 on my x squared. In order to complete the square, I have to have a coefficient of 1 on my x squared. So in order to get coefficient of 1 on my x squared, what I'm going to do is I'm going to multiply both sides of this equation by -3. If I multiply this whole equation here, and I multiply y by -3, I'm going to get -3y is equal to x squared minus, I say minus and I write a plus. Can you explain that, please? Minus 6x minus 3. Can everybody see that? I have 1/3 as the coefficient, -1/3 is the coefficient of x squared. It has to be 1 if I'm going to complete the square. So the way I turn -1/3 into 1 is I multiply by the reciprocal, which is -3. Is it anybody have a question on that? You sure? Yeah. Yes. This is one from the handout that I did, that I sent out this, I posted on Edmodo, which you are now a member of. Some problems that people could work on if they wanted to do more transformations. They were from another book that I have. No, it's not in the problems that I said. Okay. But it'll take us through a lot of good stuff. So now I have -3y is equal to x squared minus 6x minus 3. I still need to get it into vertex form. So I'm going to get it into vertex form. I'm going to take my constant here, and I'm going to add it to both sides. So I don't want to get it out of the way. So I have -3y plus 3 is equal to, let's make that plus 3 plus blank, because I know I'm going to complete the square, is equal to x squared minus 6x plus blank. So if I'm going to complete the square, I have to go b over 2 squared. So I have -6 over 2 squared, and -6 over 2 is -3, and if I square that, I get a positive 9. So this is going to equal, the whole purpose for completing the square is so I can go from a trinomial to a binomial squared. This is going to be x minus 3 squared, and on this side, it's going to be -3y plus 12. So it's starting to look a little bit like vertex form. Vertex form is where I have like x minus h squared, so I have that piece of it. And now I kind of have to move this back over here to make it look like it's in vertex form. So the first thing I'm going to do is I'm going to go -3y. I'm going to subtract 12 from both sides is equal to x minus 3 squared minus 12. And then I think I'll divide both sides by -3. So I'm going to get, I'll divide this by -3, and I'll divide this by -3. So I'm going to get y is equal to 1/3 x minus 3 squared plus 4.
What would it be?
Here, let me just write this again here. What was the question here? What happened to the negative? So I got to here, right? And my negative 3 divided by negative 3 gives me a positive y. And over here, I mean, dividing by negative 3 is the same thing as multiplying by 1/3, isn't it? By negative 1/3?
Negative. Negative one.
Is everybody okay with that? Right, so that's why I just took this negative 3 and I made this into negative 1/3 times x minus 3 squared. So that's that piece of the binomial. And then I have negative 3 into negative 12 gives me a positive 4. Is that okay? Did I take that too many steps at once? Are we okay with that? Are you sure?
Can we do Mr. LeBron's?
Yes, we will, just momentarily here.
No.
Actually, no, we're gonna do Mr. LeBron's simpler way. Yes.
Could you explain to me where you got
Yes. So, let's take this here and pull it down a little bit here. Okay. So I divided this side by 3, right? By negative 3. Let's not divide it by negative 3. Let's multiply it by negative 1/3. Same thing, isn't it? Divided by negative 3 is the same thing as multiplying by negative 1/3. So you can see how this is still going to give me y over here. And then I'm going to take negative 1/3 and first apply it to the first part of my binomial. So I have negative 1/3 x minus 3 squared. And then negative 1/3 times negative 12 is plus 4. Is that right? Okay. And the reason I did that is because I knew from the very beginning of my problem up here that my a is negative 1/3. And the a is going to be negative 1/3 regardless of what form I take. Right? So I just wanted to keep my a in that form of negative 1/3. So now I'm in vertex form. What's my vertex going to be? What's the vertex of this problem?
3, 4. Yeah.
3, 4, right? So vertex form, y equals a times h. Y equals a times x minus h squared plus k. So my vertex is going to be 3, 4. Okay? Now, let's find a different way to find the vertex. Not Mr. LeBron's way. Yes, please. Yes.
I'm just confused on when, I don't know how to ask the question, but for the part where we took the plus 3,
Yes.
I'm just confused on that.
Okay. So I had this expression on one side, and I had this expression on the other side. I need to get this expression into being a perfect square. I know that x squared minus 6x minus 3 is not a perfect square. It's not even factorable, right? But I need to have it factorable so I can have it in this form down here, right? So in order to have it factorable, what I need to do is I take my constant and I just park it on the other side of the equation. I'm going to bring it back in due time.
Oh, that's my
I'm just parking that 3 on the other side of the equation because I can complete the square if I have the x squared and the x terms. That's what I need to complete the square. Is I need to have x squared with a coefficient of 1, and I need to have x with whatever coefficient it has. And then I can turn that into a perfect square trinomial. Are we good with that? Okay. So, let's stop this.